Hello, I wanted to record a quick update about Gastronomy, which is our Fund 11 funded project to build a time-traveling UPLC debugger. So last time we showed off a command line application that could load up a UPLC program and navigate forward and backward through the execution stack and display information about what the virtual machine was doing. And this time we've really focused on providing a non-command line interface version of this. So an application that you can actually run, because not everybody likes working from the command line. But also, and maybe most excitingly, this notion of source maps. So I've got a little bit of Aiken code in front of me. It's not syntax highlighted, unfortunately, but this implements the calculating a particular Fibonacci number. We have forked the Aiken compiler, and our fork can generate source maps. We're still working with the Aiken team. We're chatting with them to decide exactly how this fits into the Aiken compiler, how we store these on disk, whether they go in the blueprint or separately, things like that. We're also talking with the maintainers of other large languages that compile down to UPLC with the hope to standardize this. So it's still early on, but we've got a kind of preliminary format inspired heavily by the source maps that PluTS generates. And the goal is for any language to be able to interoperate with Gastronomy, not just Aiken. So what this is saying is that, a particular UPLC node corresponds to this section of the code. And so, for example, down here, the 157th UPLC node corresponds to line 7, column 15, which we can see here is this subtraction statement for the code. So once you've generated that, you can open up Gastronomy, and we have this nice application where you can pick a file to run. You can enter in the parameters that you want to run it with. Obviously we will have improvements to this interface over time, but you can click Run Debugger. Now here this looks very similar to the command line interface, but it is kind of a full web app. So in the future we could run this in a browser, for example. But for now, we've kind of just wrapped it up in a Electron app. We're actually using Tari, so not Electron exactly, but similar idea. And as I step through this, initially there's a bunch of boilerplate that the Aiken code adds when it compiles the program. But around here, you can see down here, we've identified that this UPLC term that we're executing corresponds to this kind of range of code in the Aiken code. And so as I step through, multiple kind of steps of execution will correspond to the same location in the source file. But at some point it changes from to column 6. Now this might be annoying to kind of flip back and forth between your code and all that. So what we added is the ability to view the source code. And if you pick where your application is stored, it can then just load up the correct file and show you that code, and it even highlights where that source location is. Now, while I'm in this mode with the UPLC terms, navigating forward and backward is like a single step semantic. So it runs exactly one step of the UPLC machine. But in this mode, we run one step of the Aiken level code, which may involve multiple UPLC steps. So when I press next, it goes on to evaluate this equality. And then we look at this constant that's encoded. That if evaluated to false in this case, because we're evaluating it on the integer 5, it's going to check if this is equal, and that's false. So now it's going to come down here and evaluate these two functions. And so it's going to evaluate n minus 2, so that should be 3. And so we can see down here, we're now in this function with n equals 3. and that's going to run in here, and that will be, it's going to run this again. Now 3 minus 2 is going to be 0, so, or no, it's going to be 1, so it will run this line of code. It will return a 1. Now we're evaluating this other branch. So this is just super, super convenient for stepping through and understanding how your Aiken code corresponds to the UPLC. And at any point, I can switch back to the UPLC, and you can see this is that constant integer that we're evaluating. And I can see that that gets returned and then is used in other things, and I can step through the UPLC, or I can switch back to the Aiken view. So still some improvements that we need to make on the UX side, but at a fundamental level, we have the ability to run UPLC code forwards and backwards, to understand the environment of what variables are in scope, what values are in scope at the time, and then to importantly map that back to Aiken code so we can understand what our code is doing and why that pesky utility function or test or even transaction might be failing. So until next time we plan to show off the ability to kind of implement custom renderers down here in the environment for different types of UPLC terms. So basically some pretty printing and some custom visualizations that are Aiken specific. So for example, if we detect that this is an option type, then we will display that as either some value or none value. So that is what we plan to show next time, but hopefully this is making Gastronomy more and more useful every day for people building on Cardano and really supercharging their developer experience. Until then, bye.